Okay, that's good. So let's come towards the scalability and resource requirements. So how do you scale all of these resources when obviously these are very, very hungry and you need a lot of computational power to deploy all of these algorithms. So what are some of the techniques that you use?
Yeah, so the first thing you need for such an for such a data intensive endeavor is a high performance computer. So we use so obviously the resources are not infinite in our case. So what we have adopted to is GPU computing. So it's a high core setting, which was initially used for graphical processing, but we have repurposed it to scientific utilization and purposes. And what we do is we have our own HPC in our lab. We have built it in a way that we do not have a lot of nodes, but we have a lot of GPUs. So all the compute goes to the GPU, and then we settle the storage on network attached storage system. So this is an improvisation to catch up with the computational requirement of this field. And then, of course, on the wet lab side, you need the knock in, knock down, knock up systems. You need to have the cell line, cell culture facilities. And on the third side, the hospital, you need the biobank, because once you get the tissue out of the patient, it has to be handled with extreme care. You can lose the RNA expression in that tissue sample within seconds. Yeah, so you have to put it in, we call it shock freeze. So we put it in liquid nitrogen, the tissue, and then we crush it for onward processing for DNA extraction, RNA extraction, etc. So it's a very high cost maneuver that cuts across hospitals, wet labs, and computational labs. But this is what is needed to get this job done.